In this video, I want to talk about the empirical rule, and this rule can sometimes be called the 68, 95, 99.7 rule. And basically, this rule applies to data that's normally distributed. So that means when we graph the data, we have this shape that looks like a bell curve, like you see in the graphs below. And this rule says that 68% of the values you can expect are going to fall within one standard deviation of the mean. And just to clarify, where you see the -1 sigma, that's that symbol here is sigma, and then +1 sigma, that just stands for one standard deviation below where you see the minus, and the +1 is one standard deviation above the mean. And then the rule also says that 95% of the data you can expect to be within 2 standard deviations of the mean, and then you can expect 99% of the data, or almost all of it, to be within 3 standard deviations from the mean. And so that would mean that, it would be very rare for data to fall, outside of 3 standard deviations or more than that. If it is normally distributed. So let's look at a common example, and I'm going to use height of men in the United States since it's normally distributed, and we can make some sense of the empirical rule with this example. And so the average height of a man in the US is 5'9", so that's why I put 5'9" in the very center, and the standard deviation is 3 inches approximately. And so I used 3 inches. I took 5'9" inches and I just added 3 inches to get each standard deviation. I just kept adding 3 inches each time, and then I subtracted 3 inches to get the standard deviations below average. So that's where these values on the left of 5'9" came from. And so we can look at the empirical rule that says 68% of values fall within 1 standard deviation from the mean. Well, let's think about that in terms of height of men. So 1 standard deviation below would be 5'6", and 1 standard deviation above is 6 feet tall. So this rule says 68% of values are between, or 68% of men are between 5'6" and 6 feet tall. It also says that 99 or 95% of men are within 2 standard deviations of the mean. So that would be 5'3" and 6'3". So 95% of men are between 5'3" and 6'3". And then this also says that 99.7% of men are going to be between 5 feet tall and 6'6". And so you can see how this rule can help us, when we're dealing with these real life situations, estimate how many data values, or how many, men, how much of the population would fall between certain values, which can be helpful. So let's go ahead. We're going to do one more example here using the empirical rule. So in this example, we have scores on a standardized test that were normally distributed with a mean of 510 and a standard deviation of 95. Draw the associated normal distribution curve, label the axis appropriately. Then use the empirical rule to complete the following statements. Okay, so step A asks us to sketch a curve. I'm just going to sketch it down here so I have a little bit more room. So I sketch my normal curve as best I can, and then I put a line down the middle, and that always indicates where the mean is. So since the mean is 510 for the standardized test, I put 510 in the middle. And then I always draw my lines for standard deviations, and I usually draw 3 on the left and then 3 on the right, and those represent, I'm just going to put a little +1, which would be 1 standard deviation above, +2, 2 standard deviations above, and then +3, 3 standard deviations above, and then a -1, and a -2, and a -3, and those are the standard deviations below average. And so then I can use the standard deviation of 95 to actually get the values that should be associated with those standard deviations. And so I'm going to take my mean, and I'm just going to add 95 to it to get the value that would be at 1 standard deviation above. And if I do that, I get 605. And then I want to add 95 again, and I get 700. And then I add 95 again, and I get 795. And then I'm going to subtract 95 to go to the left to get the standard deviations below average. So then I get 415. And then I subtract 95, and I get 320. And then I subtract 95, and I get 225. And so those, the numbers on the x-axis here, these are all the test scores. that are associated with the different standard deviations. And so now we can go ahead and answer the question. So part B asks, 68% of the students taking this exam scored between what and what? So the empirical rule says that 68% of data fall within one standard deviation of the mean. So we're going to look at the values associated with -1 and +1, and it looks like that's 415 and 605. So if a student scored anywhere between that range, it means they're within one standard deviation away from the mean. It means that their score is fairly typical. The next question asked about 95% of students. So that would be, the empirical rule says 95% of data fall within two standard deviations of the mean. So I'm going to look at the values that are associated with 95%, and that would be the 320 and the 700. So if a student scores between 300 and 700, they're within two standard deviations away. The further out they get on either end, the more extreme it is, but they're still, I would say within that typical range. And then 99.7% of values, which is what the next question asks, are within three standard deviations of the mean. And so that would be the 225 and the 795.